Okay, this is 7.4 homework help. First problem here wants us to use sum or difference or half angle formulas to determine exact values. So it wants exact answers here. So we're going to write down these formulas real quick, or just look at the formula sheet. And we've got half angle identities right here. And we've also got the cosine and sine of sum or difference right here. So we're going to be using these formulas. Now, the first thing I do is I like working with degrees. So I like to take this negative pi over 12 and convert it to degrees by multiplying through 180 over pi, which gives you negative 15. So I'm going to use negative 15. Now to get negative 15, I'm going to do negative 45 plus 30, or I'll do 30 minus 45. So I'm going to use the difference formula on the formula sheet, which is this right here, sine of the first angle, cosine of the second angle, minus cosine of the first angle, sine of the second. And I'm going to simplify that. These are exact values on the unit circle. Sine of 30 is 1/2. Cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And the sine of 45 is square root of 2 over 2. I'm going to simplify it a little bit. I'll make it square root of 2 minus the square root of 6 all over 4. It probably accept it either way you enter it in, but I'd enter it in like this with this in parentheses on the top. Okay, the next is sine of 13 pi over 12. I'm going to convert that to degrees real quick because in degrees that's 195. So there's different ways to do this, I'm sure, but I'm going to make it 150 plus 45. Now I just use degrees because I'm more comfortable with that, than I am with fractions with radians. But you can clearly do this in radians as well. Now, I'm going to do the formula for the sine of an angle plus another angle, with this right here. And now I'm going to simplify the sine of 150 is on your unit circle. It's 1/2. The cosine of 45 is square root of 2 over 2. Plus the cosine of 150 is also on your unit circle. That's negative square root of 3 over 2. And sine is square root of 2 over 2. So this simplifies the square root of 2 minus the square root of 6 all over 4. I'd enter that in the same way I entered the last one. Okay, next one, convert it to degrees, and you get 3 pi over 8 is really 67.5, which I'm going to write that as double it, 135 over 2, and then use our half angle identity. Half angle identity is on the formula sheet, which is right here. The cosine of pi over 2 equals this, right here. Now let's figure out if it's positive or negative. So we're looking at our angle 67.5. That's over here. The cosine's positive there, so we don't need the negative. We're just going to do positive. Now I'm going to simplify this. The cosine of 135 is on your unit circle, and that's negative square root of 2 over 2. So I'll make this negative square root of 2 over 2. Now I'll combine these fractions by getting a common denominator here and simplifying. I get 2 minus the square root of 2 over 2, all divided by 2. So I'll really multiply it by 1/2 instead, which gives me 1/4 in the bottom here. And that's my answer. A little difficult to enter in. You got to use a lot of parentheses, but you could also enter it in like this: square root of 2 minus the square root of 2 all over 2, if you put this in parentheses, because you can evaluate the square root of the bottom. All right, and the last one, pi over 12, is really 15 degrees. Once again, I'm going to make this different ways to do it, but I'll make it 45 minus 30, and then use the cosine of a difference formula, which is this right here. And then simplify the cosine of 45 square root of 2 over 2, cosine of 30 square root of 3 over 2, sine of 45 square root of 2 over 2, and sine of 30 is 1/2. So this would be square root of 6 plus the square root of 2 all over 4 if you simplify. So I'm going to enter that in right here. All right. Okay, the next one I'm going to use the sine of a sum formula, which the sine of u plus v, for example, on the formula sheet, which is right here, where I've entered in u is x and v is pi over 6. And so now you can just see they want the cosine of pi over 6 right here, which is square root of 3 over 2 on your unit circle. And sine of pi over 6 is 1/2 on your unit circle. So this is right there, and this is right there. Okay, the next problem wants to find the sine of these two angles. Keep in mind the inverse sine is an angle, so let's rewrite it as the sine of some angle equals 1/2 instead of the inverse sine of 1/2. Now where does that happen on the unit circle? It's at pi over 6. So I'm going to write as pi over 6 plus, and then the cosine is the same. Now what angle gives the cosine of 1/2? That would be pi over 3. So now I can use the sum formula in your formula sheet for sine right here, which when I fill it out I get this. And then I can simplify this. The sine of 30 degrees is 1/2. Cosine of 60 degrees is 1/2. Cosine of 30 degrees is square root of 3 over 2. And the sine of 60 degrees is also square root of 3 over 2. So when I simplify this, I get 1 plus the square root of 9, which is just 3, all over 4, which is 4 over 4, which is 1. So my answer ends up being just 1 for the first one. Now for the second one, I'm going to do the same thing, only I'm going to use the cosine formula for the cosine of sum instead of sine of sum. The next problem wants me to find the exact value of the cosine of 105 and put it in this form using sum or difference formulas. So I'm going to make this the cosine of 60 plus 45, and then I'll rewrite this with the cosine for a sum, which is right here. So I get this. Now I can simplify. Cosine of 60 is 1/2. Cosine of 45 is square root of 2 over 2. Square root of 3 over 2. And sine of 45 square root of 2 over 2. Alright, now I want us to write it like this, which would be square root of 2 minus square root of 3 times the square root of 2 all over 4. Now I'm going to pull out a square root of 2, so it would be square root of 2 times 1 minus the square root of 3 all over 4. So I pull out a square root of 2 from the numerator and got this. That way my a value here is 2 and my b value here is 3. Alright, this next problem is a really tough one. It tells me the cosine of alpha is between 0 and 90 and it equals square root of 15 over 8. So let me draw right here. Now I'm going to do the Pythagorean theorem to find this, and that gives me 7. Alright, now I'm going to do the same thing for the other one here, beta, where the cosine of beta is adjacent over opposite, and then do the Pythagorean theorem to find this side. Now I can use the sum. So this is alpha, this is beta, so when I write the sum formula off the formula sheet, this right here, and now I can plug these in. So the sine of alpha is opposite over hypotenuse, which is 7 over 8, right from this first triangle. The cosine of beta from the second triangle is square root of 32 over 9, plus the cosine of alpha from the first triangle is square root of 15 over 8, times the sine of beta from the second one is opposite over hypotenuse, so 7 over 9. Now I can simplify it a little bit, and I don't know, I'll just enter it in like that. Okay, the next formula wants us to use the tangent of 75. I'm going to rewrite that because they want us to use addition or subtraction, so I'll rewrite it as 30 plus 45. Now, tangent's really sine over cosine, so I'll rewrite it like this, and then I'll use my formula sheet right here to write down these formulas. Alright, so sine is sine of the first angle, cosine of the second, plus cosine of the first, sine of the second. And then cosine of a sum is cosine of the first, cosine of the second, minus sine of the first, sine of the second. Now I'm going to simplify this to try to get it to look like this. So I'm going to replace all these with exact values. So the sine of 30, for example, is 1/2. And I'll fill in the, and I get all these. Now I need to simplify this. So it simplifies if you add the fraction scalar like this. Now I'm going to multiply by the reciprocal from the bottom instead of divide. These cancel, and I get this. I'm going to factor out a square root of 2 from the top, leave me with 1 plus the square root of 3, and then factor out a square root of 2 from the bottom, leave me with the square root of 3 minus 1. These cancel now, and that's what they're looking for right here, only they have it written the other way around. I just flip the top, and then you can see that 3 and 3 are my answers up here for A and B. Okay, the next problem wants me to find out, using this, what the cosine of pi over A would be, or b over 2. So what I'm going to do is recognize that this is the cosine formula for the sum. So if you go backwards on your formula sheet using this formula right here, so it gave me the right side, I want to equate it to the left side here. So it's the cosine of the first angle minus the second one from that formula, which simplifies to, if I add these fractions together, get a common denominator by multiplying top and bottom by 3. So 9 pi minus 2 pi is 7 pi over 21. Now 7 goes into this 3 times, so it's really pi over 3. So A is 3 in this case. And we also know that cosine of pi over 3 right under your unit circle is square root of 3 over 2. or I'm sorry, it's 1/2. So I could also say it's 1/2, or in this case, b is 1. Okay, the next one's a little bit easier. Sine of x minus pi. If you follow the formula in your formula sheet for the sign of a difference, you get this right here. And then cosine of pi, that's 180, that's -1. So it's negative sine of x minus, and sine of pi is 0, so this whole term cancels out. So it's just negative sine of x. So they say that it equals a sine of x, so a is -1 in this case. All right, and the last problem, if we fill out the formula, the cosine of some formula, that equals cosine of the first angle, cosine of the second angle, and then change the sign, and then it's sine of the first angle, sine of the second angle on the formula sheet. And we can simplify this because we know the cosine of 20,000 pi, it's an even number of pi's, like 2 pi, so we're on the unit circle at this spot right here, which the cosine of that value is just 1, and the sine of that value is just 0. So this just turns into the cosine of c, but they said, I'm sorry, it turns into cosine of x, and they said use c for that. So that first answer is just c. Now the second one's the same thing. Fill out the cosine formula, right off your formula sheet, and then simplify. So the cosine of, now if we're talking about an odd number of pi's, we're over here. So the cosine at that value is -1, and the sine of that is still 0. So it just turns into negative cosine of x, or negative c. All right, I hope this